Hello friends, welcome to Physics with Ben. In today's class, I would like us to look at a brand new topic, structure of the nucleus, also known as radioactivity. This course is divided into 3 parts, and I will be happy if you will watch all the parts to gain mastery knowledge on this topic. Without wasting much time, let us go straight to the business of the day. Learning objectives. I wish to say something brief on learning objectives before we proceed. Learning objectives in A level is also known as course outline. It helps guides the learners on what to read in any particular subject or topic. The learning objectives are also disguised form of your continuous assessment tests and your examination questions. They are also called areas of concentration. That is, if you are learning anything in radioactivity, in this first part, these areas of concentration are what you should pay more attention to. Should I or any physics teacher or any examining body want to set any questions, the questions must cross across these areas of concentration. And so by the end of this lesson, you should be able to give a brief history of radioactivity. At least you should be able to tell who came about the knowledge of radioactivity, the year, and his contribution to what led to radioactivity. Very, very important. You should be able to define radioactivity and radioactive element and hence give examples. You should be able to represent a radioactive element or atom or particle in simple nuclear equation and hence identify the mass number and the atomic number. You should be able to define radioactive particles and state their types with examples. You should be able to explain with the aid of suitable diagram the behavior of natural radioactive particles in electric and magnetic fields. You should be identify the radiations from radioactive particles, especially the natural radioactive particles, their general properties or characteristics. Distinguish between natural and artificial radioactivity. Define radioisotopes. Balance and solve nuclear equations problems. So these are the learning objectives in this first part of this course. So let's proceed. Radioactivity, also known as transformation of elements. There was an argument between some philosophers of what matter is. The definition of what matter is led to this particular topic. Contributions of various scientists. We don't want to go into all that, but we are just focusing on this particular guy, Henry Becquerel, 1891. I hope you know this guy. He is the brain behind radioactivity. A lot of people propose the atomic theory, what matter is, how matter is composed of atoms. Some group of people said that the atom is indestructible, cannot be divided. Some group of persons said no, the atom is electrical in nature. Some said it was electrically neutral. Some said it composed of electrons. And this guy, his contribution was that the atom can be divided. The atom can be splitted. to form new atoms of new elements, to form new atoms with new elements with new nuclei with different mass numbers. Sometimes the same mass number, different atomic number. So this was a contribution of this guy. Now, Henry Becquerel in 1891, a French physicist studied John Dalton's work and argued that atoms are not just indivisible or indestructible, as Dalton said, but that can disintegrate or decompose to form other atoms with different elements. This constructive argument gave birth to what we study today as radioactivity. Continuation. The phenomenon of radioactivity was discovered in 1896 by a French physicist, Henri Becquerel. He noted while performing some experiment that uranium gave out some kind of rays that would penetrate through thick black paper and affect a photographic plate placed on the other side. This phenomenon is called radioactivity, and substances that give rise to radioactivity are called radioactive substance or elements. The observation of this phenomenon was confirmed in 1898 by Maria Curie and her husband Pierre Curie. They discovered that a, an uranium or pitchblende was more intense source of radioactivity than uranium. They isolated the first concentrated radioactive substance or element called polonium and radium. Other radioactive substances such as thorium, radon, and polonium were later isolated by the Curies and other workers. So this is just a brief history of radioactivity, how it came about, the people that contributed to the topic we are studying today. So radioactivity is definition. Radioactivity is the spontaneous decay, is defined as a spontaneous decay or disintegration of the nucleus of the atom of an element during which it emits alpha particle, beta particle, or gamma rays, or a combination of any or all the three, and energy or heat. Radioactive elements are those elements that spontaneously emit radiation from their nucleus, e.g., radium, thorium, radon, polonium, and polonium, etc. Next up, we want to look at how the arbitral representation of radioactive atom or element and particle, that is the nuclear equations. The arbitrary symbol letter X is used to represent a radioactive element or atom and also a radioactive particle or the atom of the particle or the element of the particle as follows. What we mean by arbitrary here is that you can choose a different symbol, maybe maybe Y or U or T to represent this particle. As we proceed, we are going to know that the first two letters of the radioactive element or atom is used as this particular symbol. That is why I say arbitrary symbol letter X. So here we have X represented with a superscript and Z subscript, where the letter X itself stands for the atom of radioactive element or the atom of the radioactive particle. The superscript stands for the mass number, stands for the atomic mass or the mass number of the radioactive element or particle. And then the Z subscript is representing the atomic number or proton number or number of electron of the radioactive element or radioactive particle. And so from here we have a very simple nuclear equation as A is equals to Z plus number of neutrons, and this is our first equation in this topic, a very, very important equation. There are moment examiners may set equation and you have to make use of this equation before you find your way around the question. We want to look at radioactive particles and their types. Radioactive particles are those particles that are emitted by the nuclei of unstable radioactive atoms or elements. They are particles that are emitted during radioactivity from radioactive atoms or radioactive elements. These particles are categorized into two. We have the natural radioactive particles. These particles are emitted during natural radioactivity. We're going to explain natural radioactivity in the next section. So examples of these particles are alpha decay or alpha particle, with represented with with a helium atom He with 4 mass number and 2 atomic number, and the beta particle or the beta decay represented with an electron E with 0 mass number and negative atomic number. And then the gamma radiation or the gamma rays. The gamma radiation is represented with the atomic number, with the atomic symbol gamma. 00 here meaning that it has no mass, it has no atomic number. The gamma radiation is said to be electrically neutral. We are going to discuss that as we proceed in this lesson. Next up, we are looking at artificial radioactive particles. These are particles that are emitted during artificial radioactivity. Examples of these particles are the neutron, which represented with the symbol N, with 1 mass number 1 and atomic number 0. Proton, having atomic number 1 and mass number 1, and deuteron, having atomic number 1 and mass number 2, and tritium, atomic number 1 and mass number 3. So one thing that is very, very important in this topic is that these radioactive particles, the natural and the artificial radioactive particles, they are very, very important and can be used during calculations involving nuclear equations. They will tell you the radioactive element in the bid to gain stability decayed by emitting a neutron or a proton or a deuteron or a tritium. So if you don't know these particles and how to represent them, you will be confused and you will not know how to go about writing the nuclear equation. So at this point, we have 7 radioactive particles, 3 natural radioactive particles, and 4 artificial radioactive particles. Very, very important.